Next up, this is Lucas. He's a Belgian developer. And he will be talking about Kadeploy configuration management system.
First, I'd like to start by saying that I'm very happy to see that there's room at FOSDEM. So I have one foot in the software community and one in the HPC community, and it's actually really great to see those two communities reaching. It's quite funny when you attend events such as supercomputing to see that everybody is using free software, but only very few people talk about free software. So having that event at FOSDEM is really great. So I'm going to talk about Kadeploy, which is a piece of software developed at INRIA and Université de Lorraine with Lisa Zeniak and Emmanuel Jean-Marc. So Kadeploy is an OS provisioning solution. So what it does is that it makes it easier to install compute nodes using system images. So it's basically the same common space as Clonzilla, System Imager, XCAT, or OpenStack Irony. One focus in Kadeploy is that it's really designed for scalability and reliability. We provide Debian and RPM packages, and Kadeploy development starting in 2004. Kadeploy is released under the CSV license. Who knows about the CSV license? Okay, so only French people. No, you might need to be French. Are you French?
No, I'm not, but I'm not.
Good. So at least one person not French knows about CSV license. The CSV license is not invented here syndrome by several French organizations. The important part about it is section 534 that says that it's GPL and LGPL compatible. So you don't need to read the rest of it, just consider it here. So it's not factual, so I think it's So the key features of Kadeploy. So you can use it to install and configure a large number of nodes. So you can install it to install several clusters in one shot from a single client. You can also use it to install several sets of nodes at the same time. Two partitions of nodes, you can install them in one at the same time. It makes it easier to manage a library of system images. So users can provide their own system images, and you can share them to users with some permissions management. So it's built on top of standard stuff like PXE, DHCP, TFTP, and SSH. So it doesn't reinvent the wheel, it really tries to rely on existing tools everywhere where possible. So it can integrate with various low-level remote operation systems such as IPMI or Drive. It integrates with the batch scheduler, so you can use it to give the permission to users to deploy their own nodes during a job. And with network isolation tools, I'll talk more about this later. It supports basically any operating system. So of course Linux. For Linux, well, we have different formats for the system images. For Linux, for example, you can use DARGZ archives containing all the file system data. For other systems, you can use raw partitioned images, so basically the output of BSD. So you can easily deploy BSD or Windows. At one point, probably add a bigger Debian commuted to BSD deployment in the world.
Also includes macOS?
Should work, never tested. Well, usually the tricky part is post-configuration stuff to make sure that each node has its own identity. But I don't know how this would work with macOS, but it should work. It doesn't need to know anything about the file system. Like for BSD, it just writes all the data to the disk. So it's built as a service with a remote control API using REST, and it's really fast. So just to give an idea, you can deploy 200 nodes in 3 minutes. So of course that depends on mainly two things. or you reboot nodes, because most of the time you need to reboot nodes at some point if you want to restore them. And the reboot is usually the longest part of the deployment. So 3 minutes is a piece of shit using kexec that you don't go through BIOS. And also the amount of data you need to write to the nodes, of course, because that's with quite small system actions. So how does it work? So basically there's 3 entities, Kadeploy server, DHCP server, TFTP or HTTP server. So Kadeploy configures PXE profiles on the TFTP server. It triggers reboot of the nodes using IPMI or SSH. The nodes boot to a minimal deployment system that is sent over the network using either TFTP or HTTP. For example, you can use IPXE to send a small system using TFTP and then get a big image using HTTP. Then Kadeploy does all the control of the node and configuration of the nodes, sends the system images to the nodes, and then reconfigures the PXE profiles and triggers another reboot of the node, and that is the deployed system. The node finally boots to the new. So, small focus on how we do the image broadcast. So that's a tricky problem because we want to send a large amount of data to thousands of nodes, possibly thousands of nodes. And the challenge is to avoid network bottlenecks and saturation of network links. Typically, while most clusters have an Ethernet network that looks like that, so they have a hierarchy of switches, like you have one switch per rack and one core switch. And well, you could try to do that, to send from the image server to every client, but that's really stupid because then all 3 links are completely overcoded. You could use peer-to-peer, like use BitTorrent to do that, but then all nodes talking to any other nodes without really considering the locality, because locality is like there's no real way to implement locality in BitTorrent, and those 2 links get saturated. So what we do in Kadeploy is that we use topology-aware pipeline broadcast, which means that we send the data to the first node and send it to the next node, etc. So that way, each link is only used once in each direction, which means that if you have full duplex before links, everything goes fine. The limiting factor becomes backplane bandwidth of switches. Also, very recently we improved on that to handle failures of nodes during the pipeline. So if one node fails, that one will automatically reconnect to that one. So another problem is scalable remote execution commands. So how can you execute a large commands on a large number of nodes? So the stupid way to do it is to do it sequentially, like that, 1 node at a time. If you have 3 nodes, probably it's okay. If you have more than that, you're not going to, it's going to hurt. Another way is to use a sequential process plus a sliding window, which means that you connect to, for example, 4 nodes at a time. Like that. That's still linear complexity. What we do in Kadeploy is that we use a tree-based tool called TACTOOK. So there's a HPC paper there. The idea is to connect to one node and then reuse nodes that you already connected to connect to other nodes. So this one is in charge of connecting to that one. Then next step, this one to connect to that one, this one to connect to that one, this one to connect to that one. Etc. So go to logarithmic complexity instead of linear complexity. So I'm now going to talk a bit about how we use Kadeploy in the context of G5000, which is a test bed for research on distributed systems. So stuff like HPC, cloud, peer-to-peer systems, and grids. So this test bed is really for research on computer science. One of the tests we use to determine if someone should get access or not is we ask them if they are interested in the result of the computation. If they are, then V5000 is not for them. What people are interested in how to improve applications or libraries or runtimes in order to compute faster. They should not be interested in the computation itself. So V5000 is composed of 11 sites, with one site outside France in Luxembourg. Actually, we have members from local V5000 site in Luxembourg in the room. But as 26 clusters, about 1,300 nodes, 8,000 cores. The network between sites is dedicated, it's provided by the French NREN project. We provide various technologies, of course, due to the several generations of clusters we bought over the years, like Uninet and Infinitant. We have 2 GP clusters and 1 mid cluster. And there are about 500 different users using the testbed per year. So it really works. So what we do with Kadeploy in V5000 is that we provide, just to use a cloud buzzword, an hardware as a service cloud. So we give the user the ability to reserve nodes and reinstall them with their own software stack. So they can get root access, but not in a virtual machine like you would get in a typical cloud infrastructure, but on the bare metal. So we provide standard environments to users using on various Linux distributions, and tools to automate the deployment of cloud stacks. For example, it's easy to install your own OpenStack instance inside V5000. Kadeploy is also integrated with KVLAN, which does network isolation. So the idea is to allow users to isolate from the rest of the testbed for the duration of their experiment. So, for example, they want to networking experiments where they really want to avoid getting polluted by broadcasts from another experiment or unsolicited connections from another experiment. You can also use it to enable users to avoid breaking the rest of the testbed. Like using KVLAN, you can start your own DHCP server inside your job and not conflict with testbeds one. Some people use it to experiment on Ethernet-based protocols at large scale. And we can also use it to interconnect nodes with another testbed without compromising the security of V5000. So you can take a piece of V5000, connect it to another testbed for the duration of the experiment. So what we did with V5000 and Kadeploy is that we did some kind of inception, if you saw the movie. We use V5000 and Kadeploy to test Kadeploy. So we created a cloud of virtual machines inside V5000 and reinstalled those virtual machines using Kadeploy. That shows that Kadeploy can scale well to at least 4,000 machines. Okay, so that's the end of my talk. So pointer to the Kadeploy website is there. 5000 website is here. We have an open access program available for V5000. So if you are interested in trying with it, just register there. So it's kind of designed for people from academia. You need to enter your university and lab, etc. So if it doesn't work for you because you are more into if you are here as a free software developer and not someone from academia, just mail me and we'll figure it out how you can get access. Thank you.
All right. Any questions?
I discovered the Kadeploy 10 years ago, and I got impressed by the ability to be writing in a different language very often. And I was wondering, how stable now is the source code of Kadeploy?
We have no internet connection.
because I saw it in C, in Perl, in C++. I was wondering, yeah, it's quite difficult to compile all these.
Yeah, well, the development started in what I put 2004 in the study even earlier, so rewriting from scratch from time to time is not necessarily a bad idea, and just to clean up all the crap that they've accumulated over the years. Well, we switched, I think it has been Perl between 2004, 5, and 2008, and Ruby since then, so it's not that changing. The current code base is stable, maintained, and we don't plan to switch to any other language anytime soon.
At what level do you handle network isolation?
For KVLAN, what we do is we have bindings for each switch manufacturer that we use in F5000, and we just connect to the switch using SNMP or SSH and change the VLAN. Yeah, it's VLAN.
For the broadcasting system, why didn't you use something like that?
Yeah, interesting question. So we worked on the resilient thing recently. We compared with UBPcast, which is an implementation of reliable multicast. So the main problem with multicast is that, so first it's UDP based, and one way to make sure that everything gets transferred to all nodes. So to do that, what UDPcast using two different sheets. One is it sends fake packets in the middle of the transfer to make sure that if you lose some packets, you can rebuild them using the fake ones. That is quite hard to tune because it depends on the network saturation at the time of the transfer. Depending on how many other users are using the network at that time, you might lose less or more packets, and adjusting the fake parameters is really hard. It's really hard to get new patterns. The other way that UDPcast works is that at the end of the transfer, the nodes send a report to the main node saying, I lost this set of packets. And that doesn't scale very well if you have a lot of nodes. It works fine. So we have experiments, I could send you the paper if you want to with experiments showing that it works fine until 30, 40 nodes. But then at some point, the fact that every node needs to send a report saying I lost those packets and the main node to send them again kind of loses all the advantages.
How do you manage the locality of nodes regarding the switch? Is it by discovery or is it by topology that you provide it to the system?
Yeah, no, we provide it to the system. We assume that nodes are numbered according to the physical location. Well, you can provide another sorting order if you want, but that's usually quite sane to assume that nodes are racked in order.
If one knows experience our app and other failure during the deployment?
So Kadeploy uses a workflow engine internally, so it works with timeouts and retry policies, so that if one step fails, it can retry that step on just that node and the node that failed. Well, of course, you can disable all timeouts if you just want to get as many nodes in one run, but in practice, if you want to get all the nodes that sometimes, well, failures happen for many reasons.
And does it trigger a new path, or because the chain might be broken?
So if the chain gets broken, so it's not, so yeah, the part about, the part about scalable chain is not in the current release, but will be in the next release. And if one node fails, the previous node reconnects to the next one automatically and resumes the transfer while it's stopped. And then if for some reason the whole operation, after that operation, for nodes that failed, the deployment can automatically fork and do a second try of the pipeline broadcast with the nodes that failed. That's handled transparently, and you just end up with two different sets of nodes progressing in the various steps.
All right. Thank you for the questions. Thank you, Lucas, for the talk.